All right, here we are with systems of equations with me, Mr. Hain. And the essential question for this section of the video is, what does the solution to a system of equations represent? All right, let's dive right in. Okay, first we're going to consider the question, is the ordered pair a solution? So I have a system of equations here and an ordered pair, two of them. So I'm going to check if that ordered pair satisfies the system of equations. So really, I'm going to take the first equation, x plus 2y equals 2, and you see in blue what I've done is substitute in the 4 and the negative 1 for the x and the y. Now all I'm going to do is check to see if it does equal what the equation equals, which is 2. So multiply, 4 minus 2 is 2, 2 equals 2. Excellent. That means that this point, 4 minus 1, or 4 comma negative 1, rather, is on the line x plus 2y equals 2. Excellent. So I need to check to see if that same point is on the second equation. So you see me substitute in red 4 minus 2 times negative 1 equals 6 into the second equation, the same point. A little multiplication, a little addition, and I see that 6 does equal 6. What does this mean? This means that the point 4 comma negative 1 satisfies both the first and the second equations. So it is on both lines. That means it is a solution to the system of equations. Yes, 4 comma negative 1 is a solution. Now, what this also means is that if I'm taking a look at the second point, which is negative 4 comma 3, it should not work with both equations. It might work with one, so let's just plug it in. So let's consider the first equation. And it does work when I substitute in negative 4 and 3. Now, if I substitute in negative 4 and 3 to the second equation, I end up with negative 4 minus 6 equals 6. Well, negative 10 does not equal 6. That means that the second point, negative 4 comma 3, is not on the equation x minus 2y equals 6, is not on the line or graph of that equation. So negative 4 comma 3 is not a solution to that system of equations. All right, so go ahead, use the equations in checkpoint 1 to check and see which one, A and B, satisfies both equations. All right, cool. Pause the video. I'll be here when you get back. And now we're going to solve by graphing. And I know that this is kind of me previewing the next lesson. So if you're seeing this on YouTube and you're checking out the next lesson, it'll also be there in more detail. So first, I'm going to graph both equations. So I'm going to graph the first one, y minus 3x, y equals negative 3x plus 2. I've got my y-intercept, which is 2, my slope, which is negative 3, comma 1, or not, negative 3 down and 1 to the right. I'm going to graph my second equation, y equals 5x minus 6, so negative 6 is my y-intercept, up 5 over 1, I connect those dots, and I see that when I do, the solution is actually where those two lines intersect. And that's what the essential question is asking. What does a solution to a system of equations represent? It represents where those lines intersect, right here, 1 comma negative 1 for these two. And if you've got some graph paper at home, go ahead and graph the two lines in checkpoint 3. See where those lines intersect. Be real careful. Use a ruler. I'll be here when you get back. All right, and so let's talk about infinite and no solutions. So the three different cases that you can get when you're dealing with a system of equations. All right, more often than not, you're going to end up with exactly one solution. That just means that the two lines intersect at one point. And you see here, solution. All right, but what happens when the lines have the same slope and a different y-intercept? Well, those lines are parallel. Now, if the lines are parallel, you know about straight lines. If they're parallel, they never touch anywhere. So that means if the solution to a system of equations is where the lines intersect, if the lines never touch, there is no solution. Parallel lines, no solution. Which brings us to the third and most interesting case, which is infinite solutions. What that means is that no matter what the two equations look like that you're using, if you solve both of them for y, or if you graph both of them, or however you solve them, you end up seeing that it's really the same line overlapping. And if that's the case, then every single point on one line touches every other point on the other line, which means there are an infinite number of solutions, because in reality, they're both the same line. Awesome. All right, so let's take a look at these two situations, example 4 and 5, and see what it means. Now, they say solve by graphing, so we're going to solve by graphing. So if I look at the first one, the key thing to note is that they have the same slope but different y-intercepts. And you see that when I graph them, they are indeed parallel, which means there is no solution. All right, so let's take a look at example 5. If I take a look at example 5, I'm going to take the first equation and I'm going to solve it for y. So I'm going to move the 2x and I get y equals negative 2x plus 3. Okay, cool. The second equation, I'm going to move the 4x and then I'm going to isolate the y by dividing by 2, and that gets me y equals negative. Wait a second. That's the same equation. Since it's the same equation and I'm presented with 2 of them, that means I have an infinite number of solutions. Okay, so I want to go back to the example 4. Example 4, I really didn't even have to graph it because they're both solved for y. I see they have the same slope. The coefficient of x is 2 for both of them. That means that if I have the same slope and different y-intercepts, I automatically know it is no solution. I do not have to graph them. So use the examples here to guide your thinking when you are solving checkpoint 4 and checkpoint 5. Go ahead and pause the video. I'll be here when you get back. Awesome. So now we're going to solve some systems by substitution. And that's the section of this video with, of course, again, me, Mr. Hain. And our essential question for this section of the video is, how does solving for a variable help me solve a system of equations? This is a leading question. Let's dive right in. Okay, so for example 1, I see that I already have the first equation solved for y. And this is important. The second equation is not solved for y, but since the first one is already solved for y and y is alone, that allows me to take the first equation, and since I know what y is equal to, negative x minus 1, I can substitute that in for the y in the second equation. So you see, instead of writing the variable y, I literally put in the value for what I know y is, negative x minus 1. It's multiplication, so I use the parentheses, and I'm going to distribute. So I distribute that negative 3, and after I've distributed, I can combine like terms. So 4x plus 3x, that gives me 7x, and then I can subtract 3 from each side. That gives me 7x is equal to 21. Inverse of multiplication is division, so I know that x is equal to 3. Okay, so we recall from the previous part of the video that the solution to a system of equations is a coordinate point. So now I know the x coordinate point, so I got to solve for the y coordinate point. So I am actually going to substitute that back in to my first equation. So I put in 3, so that becomes, instead of negative x, it's negative 3 minus 1. And I know what negative 3 minus 1 is, same signs, add them up. Shaboo, it is negative 4. So now I have an x and a y, and I know my solution is x comma y, 3 comma negative 4. Awesome! Whew! All right, cool. So in a quick recap, I saw that it was solved for y, so I substituted it into the second equation. I then solved for x, and when I solved for x, I plugged that value back in to my first equation. Then I solve for the y, and my coordinate point, x comma y, is the solution to my system of equations. Whew. All right, let's take a look at example 2. For example 2, I like the second equation. The reason that I like it is I have a variable with no coefficient. All right, this is when I want to use substitution. I want to use substitution when I have a variable in a system of equations that has no coefficient. So now I'm going to take that equation, I'm going to subtract for x, and I'm going to divide by negative 2 so that I know what y is equal to. So I'm going to do this the hard way, but hey, it's funner that way. Yes, I said funner, which is not a word, sorry. All right, so I'm going to take what y is equal to, and I substitute that in to the first equation. Now, don't get scared. I have negative 4. What's half of negative 4? It's negative 2. Negative 4 times 3 is negative 12, and negative 12 divided by 2 is negative 6. All right, cool. So let's combine like terms. I have 3x minus 6 is equal to 9. Isolating for x, I see that x is equal to 5. And I can substitute that back in to my original equation. And half of 5 is just 5 halves. And 5 halves plus 3 halves is 8 halves. And 8 divided by 2 is 4. I've got x, I've got y, I have a coordinate point, and that is my solution. 5, comma 4. Awesome. Okay, so use this information and go ahead and solve checkpoint 1 and checkpoint 2. I'll be here when you get back. So let's take a look at some interesting cases. And we're going to solve both of these by the substitution method as well. So in example 3, I see that my second equation is already solved for y. Okay, so what I'm going to do is I'm going to isolate the y in my first equation, and then I'm going to substitute it back, and then wait, hold on one second. When I distribute the y in my first equation, and then subtract the 1, I notice that it has the same slope as my second equation. Wait a second. Same slope, different y-intercept. We know what this means. No solution. All right, so let's take a look at example 4. If I see example 4, what I'm going to do is I see that I'm going to substitute in the y here to the second equation. And when I do, I distribute, and I have 4 and negative 4. So I have that 4x minus 4x. What does that mean? That means it cancels out. And when it cancels out, 6 is equal to 6. Well, if 6 is equal to 6, I have infinite solutions. Let's see this another way. So the other way I could do this is I could take the second equation, isolate it for y, divide by 2, and I have y equals 3x minus 2x. Wait, hold on one second. See, that y equals 3x minus 2x, that's the same as the first equation. And if it's the same as the first equation, then I have the same equation. Infinite solutions. So I've solved example 4 two separate ways. The first way is by substitution, and the second way is isolating the second equation for y, and then I see I have the same equation. Awesome. Use what we just explored to solve checkpoint 3 and checkpoint 4. I'll be here when you get back. And that's the end of the video. So ladies and gentlemen, until we get back, keep doing the math.